So we left off last day. I think I had played for you the periodic table of the elements song. Oh, there's more where that came from. So I said, pause here. Let's meet the elements. That's what goes in that little blank. So it turns out that there are 92 elements that occur naturally. Most of them are forged inside the center of stars in that fiery crucible. But we can do better in labs. We can create a few more. We can create around 25 or so. But most of those ones have half-lives of tenths of seconds or hundredths of seconds or even as little as trillionths of seconds. They exist and they're gone. They decay very fast. Most of the time, Brooke, they're highly radioactive. But that's some of what they're doing at the, if you've heard of the Large Hadron Collider, that's some of what they're doing, and other places as well. Everything else in the universe is made up of a combination of those 92, including you. You're mostly carbon with other stuff. All elements are represented by a 1 or 2 letter symbol. Wait a minute, Mr. Dueck, on my periodic table, when I'm looking at 114, 115, 116, some of those have 3 letters. Those are placeholders. Right now, there is a process in place to give those official names, and once they've done that, then they will also have a symbol. What does it say, Cole, since you have yours out? What is 118 called? Oh, that one has a name? What about 116? Does that have a name? Unihexium. Is it unhexium? Okay. French, 1. 1, hex, 6. It's a placeholder. It literally says in Latin 116. And we'll get to naming it once we'll name it after someone, a famous scientist usually. Okay? So those are the exceptions, but that's because they're not names yet. Some of these names make sense. Carbon is C. Some of these names don't make sense. Gold is A, U, which is the dumb joke. If it's 2 letters, the first letter is always capitalized, the second letter is always not, and I will be fussy on that. If you tell me that gold is that, I'll take a half mark off. It's not. So 1 or 2 letters, first letter always capitalized, second letter, if there is one, always lowercase. So elements in our lives, I wrote here. This is not in your notes, I don't think. If you think about your headphones, for example, what are they made of? Well, it turns out copper in the wires carries the signal from the music player to the headphones. Copper is a very good conductor. Not the best conductor. Silver and gold are better conductors, but they're so stinking expensive. Copper's the 3rd best conductor, but it's way cheaper, so we go with that. Gold is used in your headphones to help transmit the signal, a little bit of it. There are magnets that convert the signal into sound by making, we'll talk about that if you take Physics 12, but those are made of iron and boron and neodymium and other rare earth metals. So they're all around you, and the elements are all around you and in you. You're, as I said, mostly carbon. We can break elements into 3 main groups. There are metals, which is most of them, about 80%. Leave a space, don't fill in the next line. There are non-metals. If you look behind you, on the right-hand side, the darker blue section, that looks kind of like a little triangle-y shaped, those are the non-metals. The yellow ones and the ones to the left of the yellow ones, green and silver, those are the metals. And then in between those kind of pinky, there's some that behave a little bit like metals and a little bit like non-metals. They have some properties of both, which is why I said leave a space, because they're in between. We call those The metalloids. The metalloids. That's our way of saying, well, they're sort of metal, sort of not. Is that labeled on your periodic table? I can't remember.
Yeah,
There's a little staircase.
yeah.
Okay? That's the breaking point. That's the break. And you can see, if you look at that, everything to the left, most stuff is metals. To the right, the rest is mostly non-metals. There's that little staircasey thing. Those are the ones that kind of behave somewhat like metal, somewhat like not. Silicon is a metalloid because in the right situation it will conduct electricity, but also in the right situation it won't conduct electricity. It's why we make computer chips out of silicon, call them semiconductors. Semi means half. They conduct half the time, they don't half the time, which means we can turn them into little on-off switches. Yay, we like that. Metals. Most elements. These are usually hard at room temperature. They're usually solid. There is one exception. There is one metal that is a liquid at room temperature. For a candy, does anybody know what it is?
Mercury.
Mercury. Nice. Someone said, who said mercury over here? He was first. I'm sorry, but next time raise your hand. Candy for you later, Brian. Oh, wait a minute. Okay. I'm going to write this out just once, but from now on, I'm going to start to use the abbreviations because I tend to abbreviate. Mercury is a weird one. It's Hg. Okay. What else? They're shiny, which makes sense because when you think of a metal, you're probably thinking of something shiny. So you kind of know that already, but now I'm formalizing it. And they conduct electricity. Okay. They are I spell malleable right. Yeah, I'm spelling it right. Malleable, M-A-L-L-E, able. What that means is, and you may have noticed, with metals, you can, if you're careful, bend them. They're shapeable. Okay. Non-metals, if you try and bend them, they break. They're brittle. And ductile. Who remembers, because it was on your test, I think, what ductile meant? Yeah? And this is how metals are ductile. You can make wires of them. Well, of course, because wires are made out of metal. That's kind of how I put it all together. You can put in brackets if you want here, wires. That's why we make wires out of metal. They conduct electricity, and yay, they're easy to make. Oh, I did put it in brackets? Wow, that was nice. Some examples of metals. Hey, look at something from the left side of your periodic table. By the way, there is one element that behaves like both. And you can tell it behaves like both a metal and a non-metal because it's on either side right at the top. Which one? Hydrogen. Hydrogen is an extra special element. It was formed during the Big Bang. We're going to talk a lot. You can take an entire year-long university course looking at nothing but how hydrogen behaves. So hydrogen is like special, okay? It's like the kid that sits by himself in the corner. It can kind of do a little bit of whatever, all right? But otherwise, everything else on that left-hand side, lithium, beryllium, boron, sodium, magnesium. Let's do the most common ones. What are some metals that you already know are metals?
Gold.
What's Cu? Copper. You don't have to memorize it, but you probably will because we'll use that one an awful lot. Gold, I don't want to write gold. What's the abbreviation for gold? Au. Okay. Titanium, zinc, all those. But also some obscure ones. If you go further down, you might see some words that you've heard before and okay, that's a metal. Non-metals. Only a few elements. They are usually gases at room temperature, or if they're solid, they're very brittle, crumbly almost. But also often they're toxic, so it's not like you can say, hey, I'm going to use my hands on it. You need like fume hoods and gas masks and stuff. except for bromine. Bromine is the only one that's a liquid at room temperature. So there, as hopefully I've told you, there's going to be exceptions to all the stuff that I tell you. I'm going to give you, Brady, some general rules about the periodic table, but the further down on the table you move, the more haywire the rules no longer quite work and go. But everything that I tell you will be pretty good for like the top 3 or 4 levels. And we'll stay there almost all the time. How do we define? Well, because they're non-metals, we define them the opposite of metals. They're not shiny. They're not malleable. They're not ductile. They don't conduct electricity. So some examples, well, from your periodic table, from that little right-hand section there, read me a few. Carbon is a metal, carbon might be a metalloid, but nitrogen definitely. Oxygen. Go further down, be esoteric. Iodine or iodine if you're British. Yeah. Radon. Is radon R or R? No, radon is Rn. Krypton, which you thought was only a planet from Superman. No, it's actually an element, it turns out. Okay. They took the name from there. A bunch. Okay. Then we have the metalloids. Some elements. And they have some of the properties, Brooke, of metals and some of the properties of non-metals. Examples. Well, you ready? Look up. The purple ones there. So on your periodic table, looking at that staircase, you can kind of figure out, starting in row 13. So what's the first one right there? Boron. Okay. And then silicon, right below it is, which one? GS is germanium, named after, no, right below silicon. Oh, it's GE, germanium. Okay. Found in Germany. They got to name it after themselves. Yeah. So arsenic, I think, yeah. Also poisonous, go figure. What's this one here? SB, which is antimony. And then here, so those. Let's do the more common ones. Boron and silicon, because those are the ones that you will come. Certainly silicon has become very important in computer technology. Okay, so example, B and Si. That little staircase. So there's the picture there. Non-metals, and you can see, although hydrogen, element number 1, is over here, this picture colored it as a non-metal because it kind of more behaves like a non-metal than a metal. In particular, it doesn't conduct electricity very well. But for other reasons, mathematically, it combines with things like a metal, and so it's kind of a weird one. Elements close to each other generally have similar properties. Those that are far away from each other generally have very different properties. Where do the names come from? All these names and symbols. Well, some are from Greek and Latin. Some of the more recently discovered ones are named after famous scientists. You'll see there's an Einsteinium, a Rutherfordium. Okay. There is one element that's unique. It's seaborgium. The reason seaborgium is unique is at the height of the Cold War, US and Russia in the 1950s didn't like each other. And among other things, there was a race in the Russian science community and in the US science community to discover new elements by making them in particle accelerators. And the US knew that. The Russians, what is seaborgium? Element number what? It's near the bottom there somewhere. Element number? Yeah. Okay. Element number 106. The U.S. knew that the Russians had run an experiment and had created element 106, but were just running the numbers to prove that they had created it. The U.S. had also created element number 106 just after the Russians, but the U.S. wanted to name it after something in the U.S. Now, much of the elements for a while were being discovered at the University of Berkeley in California. Can you find berkelium near the bottom? Probably element around 100, right? They found that one. Then they found another one. They called it Californium because they're literally naming it after the university. Okay? The University of Berkeley was at the cutting edge of discovering elements. The person in charge of the University of California at Berkeley of their particle accelerometer was a beloved science figure all across the planet. His name was Glenn Seaborg. And so what the U.S. did is they named element 106 Seaborgium because they knew the Russians would say, oh, he's so nice, and he's still alive. We can't change the name. He is the only person who was alive when the element was named after him. The rules are it has to be named after somebody who's passed away. But there's a great photo of him. He's about 85 years old, smiling sheepishly next to a big wall-sized periodic table pointing at the element that's named after him and kind of, yay! Hashtag nerd trivia. Okay. Where do the symbols come from? Sometimes the Latin name for something, even though we use a non-Latin word as a name. Example, lead, which is PB, because that comes from the Latin plumium, or plumber, or because lead pipes used to be made out of lead. Okay. It says, see page 44 for a list, then complete the worksheet. Let me just see what I'm talking about here. We might continue on, so let's keep going. A few special ones, a few cool ones. Mercury, the liquid metal. So mercury is the only metal that is liquid at room temperature. It's very toxic. It's very toxic. We didn't know that for a long time. In fact, if you talk to Mr. Perugia or me, when we were in science class, we were actually given mercury to play with in our hands, and it's really cool because it has such a high surface tension that when you put mercury in your hand, it almost forms into a liquid marble. It's not like water that spreads out like a puddle. It almost beads up, and you can like let it roll around, but what you don't realize is it's giving off small amounts of gaseous mercury, and you're inhaling it, and we have no way of curing mercury poisoning. It bonds with stuff in your brain, and it does bad things. So now mercury is kept under lock and key. All those old style thermometers, the ones that looked red in the middle, that was often mercury. We've phased those out. You maybe can get them in old stores, but most thermometers now use something different. We've clued in, but we've also dumped a lot of it into our oceans. Yay, stupid people. Anyways, read along with me. So it says, it's the only metal that's liquid at room temperature. This doesn't make it really different from the other metals, as they are all liquid at some temperature. I can get any metal to melt. It's just the rest of them, you got to heat them up. Okay. Toxicity. Liquid elemental mercury is not that toxic, but the gas it gives off is. You would have problems if you ate it. There's the expression, mad as a hatter, and that came from back 100, 150 years ago. The felt hats that were made, the mercury was rubbed onto the felt hats as a preservative, and these hat makers were inhaling it all the time, and it does make you go loopy. That's where the expression, and if you watch Alice in Wonderland, the Mad Hatter, that comes from that expression. So if you're around mercury, don't breathe it. There is some mercury in fluorescent light bulbs. If you are in a room and a fluorescent light bulb breaks, leave for a few hours. You just don't want to breathe it. We have no technology. If you breathe in mercury, we don't know how to get it out of your body, and it doesn't pass through your body. It just stays there. Long-term environmental exposure to mercury is more problematic. It can lead to problems with the central nervous system, coordination, and if you're a woman and you're pregnant, it can also lead to developmental problems for fetuses or young children. And this is non-reversible. We have dumped a lot of mercury into our oceans. All of you have far more mercury in your body right now than your great-grandparents did. far more. And if you eat a lot of seafood, I'm sorry, there is mercury in seafood. It may be 50 or 100 years from now, we might have to just tell people can't be eating seafood anymore because we dump so much of it in the oceans, and it just stays there and cycles through. The fish swallow, it goes up to the bigger predator, then the tuna eats the smaller fish. Well, the tuna eats like 500 of those smaller fish, so it's got way more mercury than you ate the tuna. There you go. This isn't fun science, Mr. Dueck. It's very dense. I told you that we didn't know how toxic it was for the longest time. This guy is sitting on liquid mercury the same way you float in a swimming pool, but it's so dense that you literally float like you're on an air mattress, like right above it. Now, what he doesn't, he's also inhaling some of the gas. That's bad. I would never do that now. And you can see this is an older picture from like the 1950s or 60s. It's cool, but ooh. So it's very dense. In fact, a brick would float on it. Now, it also has some great uses because we can combine it with other stuff and then it's no longer toxic. So it's used in dental amalgam fillings. Many of you might have a filling in your mouth that contains some mercury, and that's safe because it's bonded with something else. So even if it does flake off, it's not going to bond with your nervous system. It's already bonded with something else. It's used to make sparkless switches. Because it's a metal, it conducts electricity. But Brady, because it's liquid, you can design a switch so that when you tilt it and the mercury runs down here, now the electricity will conduct. And then when you tilt it and the mercury runs down here, now the electricity won't conduct. So you can actually build a switch that goes on and off based on how you tilt something. That's handy. It's used in mining to purify gold, etc. This has led to significant environmental problems. They often just release it into the ground. It goes into the groundwater. It goes down to the ocean. It's the Great Circle of Life symbol, the Great Circle of Life. Although this would be the Great Circle of Death symbol, the Great Circle of Death. And thermometers. Although we're phasing that out. Now usually thermometers contain a special type of alcohol that's very heat sensitive. Again, if you're at home and you have a very old thermometer, in particular, maybe the one that your mom or dad, most of the ones now are electric, they put them in your ear, but if you have one of the old ones that used to go under your tongue, some of those, your folks might have had that for like 20 or 30 years. If you're not sure if it breaks, leave the room for a while, clean it up properly, but don't breathe in the fumes. Put your pencils down. Hydrogen. Another special element. It's the lightest. By the way, putting your phone away permanently. The further down you go, the heavier you get. So hydrogen, which is the first element, is the lightest element in the universe. Helium is the second lightest element in the universe, which is why we often use helium for party balloons. We used to use hydrogen, but you'll see why we don't later. It's the most abundant element in the universe, by far. It's very reactive, so you rarely find it in nature. Look, there's nothing but hydrogen. Usually when you find it in nature, you'll find it bonded with something. For us, for example, the classic is water. Water is H hydrogen, 2 hydrogen atoms, 1 oxygen, and we can break that apart and pull the hydrogen out of the water. It's pretty easy to do. So it's usually part of a compound. Hydrogen gas is very flammable. It's one of the fuels for the space shuttle main engine used during liftoff. It says, see video. Put your pencils down. It was also used for blimps at one point because it's so light. What could go wrong with that? So you may have heard of the Hindenburg, which was a blimp that caught fire when it was trying to land in Chicago and had, I think, about 100 people on it. You can see the video if you go to YouTube. You can watch the news footage because there was a reporter there ready to video it landing, and then all of a sudden it just catches onto flame and burns. So now we use helium. It's flammable, very, 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 very flammable. But so explosive actually, depending on how flammable something is, that determines whether it's explosive. Wood is flammable. Yes? Burns really well. Does it explode? No. Hydrogen is flammable, so flammable that you would call it an explosion because it burns so fast. Kind of like this. I've already given you the sheet, Survey of the Elements, Exploring the Periodic Table. That was the dumb, terrible puns thing. But I also have here Section 2.1 homework. That's what I just handed out. Can you take a look at it? I'll give you some hints and I'll walk you through it because some of this you might need to go to your textbook for. So here we have learning chemical symbols. Write the symbol name next to the blank. Write the symbol name next to the blank. Write the symbol name, getting you familiar with it. Then it says, and this is going to be a contest we're going to have. Number 5 says, use the chemical symbols to write 3 English words. So for example, you can write the word none. It's nitrogen, oxygen, neon. Okay? We will have a contest. Whoever can come up with the longest English word made up of nothing but letters from the periodic table will get a candy next class. I had a kid last year come up with a 21-letter word, so that's what you have to beat. Okay? Can be done. So, pardon me? No, that'd be cheating. Do it honestly, please. Okay? Look at the next page. These are the elements in the Earth crust. Here, if you're wondering what the Earth is made of, mostly iron, then a lot of oxygen and silicon, and then smaller chunks of stuff. That's the whole Earth. The crust, which is the outer part of the Earth, has lots of oxygen. Now, the oxygen is bonded with other things. That's why it's not like the Earth is made out of a gassy material. You don't sink into the Earth. See if you can kind of figure out from the chart what we're going with there. Then look at the next page. Here are some questions to answer. And then this is what I want to talk about, a survey of the elements, this sheet here. Okay? If you go to your textbook, pages 42 to 45, you will find it has about a little paragraph on about 10 different elements. You can find the answer to these clues in those paragraphs. So it's page 42 to 45. I'll show you what it looks like on mine. Here, page 42. Oh, there we go. So it walks you through this a little bit, but where you really want to look is where it says a tour of some common elements, which starts on page, I think, 43, Nope, 45. 45, it has a little paragraph on hydrogen, a little paragraph on iron, a little paragraph on oxygen, a little paragraph on sodium, a little paragraph on chlorine, on mercury, on silver, and on silicone. You can find the answer to all of those clues in that paragraph. I'll go over that with you guys next class so you can see if you've done it right, because I don't think I attached the answers for that one. I think all I attached was the answers for was the section 2.1 homework, right? Yeah, I did give you answers for that, but not for the little fill in the blanks. Nick?
Is this due tomorrow?
If you can get this done, there's 20 minutes. You can probably get it all done in class. I'll be moving on and giving you a bit more tomorrow. This is hopefully due tomorrow if you don't want homework for the long weekend. That's kind of our goal.